Now, this is another question that we are given to solve. Find the square root of 5 plus 12i. This is a complex number. So this I is a complex number. So now let's dive into solution. Then we have 5 plus 12, 2i. 5 plus 12i, I mean. We have 5 plus 12i. So we want to evaluate the square root of this. We can apply the Murphy theorem in solving this question, and we can also apply the knowledge of sort in solving it. In my previous video, I've made video on the Murphy theorem. So that is when you have seed equals to cos theta plus I sin theta. We can apply this knowledge in solving, or this method in solving this, but we are going to use sort in solving it. So I is a complex number. I is a complex number. We have I to be square root of minus 1. So therefore, whenever you see I, you are going to put square root of minus 1 there. So don't forget I said this method can also be used in solving it, but this will be longer compared to this. So it will be longer. If you are not with calculator, we are going to take time to solve using this method, but let's apply knowledge of sort. So we have this, so that is we are given this complex number 5 plus 12. In place of I, we are using root of minus 1 there, because I is a complex number whose value equals to the square root of minus 1 in a complex world. So no longer in the real world now. We are in the complex world using the complex number I, which equals square root of minus 1. Now, let this equals to, we take a number represented by letter A and another number representing by letter B. So let this equals to root of A plus root of B. Don't forget I is root of minus 1. This is the same thing as this. So now by square both sides, when we square both sides, both sides. So that is, we have square root of 5 plus 12 root minus 1 squared equals to square root of A plus square root of B, everything squared. So this square root and power of 2 will cancel out. This will cancel out. We have 5 plus 12 root minus 1 equals to, now when this is expanded, you are going to have root A by root A, you have A. Root B by root B, you are going to have B. Root A by root B, that will be root AB. Root B by root A will be root AB. When you add together, you are going to have 2 root AB. That is the knowledge of binomial expansion. When you expand this one using binomial expansion in knowledge, so you are going to obtain this. Now, let's equate like terms on both sides of the equation. The one with root we equate together, and the one without root we equate together. So it implies that A plus B equals to 5, equation 1. So this has no root. We equate to that is real number here. Then this one complex we equate to the one that is having root. So we have 12, that is, let's bring the unknown here. That is AB square root multiplied by 2 equals to 12 root minus 1. Now let's simplify this before we name it as equation 2. Now when we divide both sides of the equation by 2, 2 goes here. We have just to reduce the number that we have there. Root AB is left here. Then on the other side we have 6 root minus 1 is left. Now once again we are going to square both sides. We want to eliminate the square root by squaring both sides. The power of 2 and the square root cancel out. We have AP equals to 6 squared. That will be 36. Then square root of this square root and the power of 2 will also cancel out. We have minus 1 left there. So that implies that we have AB equals to minus 36, equation 2. Now, from equation 1, we are going to make either A or B the subject of formula from equation 1. From equation 1, from 1, we have A plus B equals to 5. This is equation 1. By making B the subject of formula, it will lead to, so 5 minus A, take A to the other side, we have equation 3. Substitute equation 3 into equation 2. We have that wherever you see B, you are going to put 5 minus A there in this equation now. That is, we have A times B, and B is 5 minus A. 5 minus A, then equals to minus 36. Now open bracket, we have 5A minus a square equals to minus 36. Now we want to form quadratic equation whose leading term will be the power in a square. So therefore we are taking a square and 5a to the other side. So when you take a square and 5a to the other side, you'll be having a, we are going to obtain, we have a squared, this will remain here, then 5a is coming, we have minus 5a, so minus 36 equals to 0. Now factorizing this will lead to a square. What are the two factors? Whose product is 36 minus 30 and sum equals minus 5. So by taking minus 9 and you multiply with plus 4, you are going to have minus 36, then minus 9 plus 4 will give us minus 1. Therefore, the two factors in which we are going to replace this minus 5a with will now be minus 9a plus 4a minus 36 equals to 0. Now, a is a common factor here, a minus 9, then 4 is a common factor here, we have a minus 9 equals to 0. Therefore, we have a minus 9 to be 0, a minus 9 multiplied by a plus 4, which implies that a minus 9 equals 0 or a plus 4 equals 0. So that is the implication there, which implies a equals to 9. A equals to 9 or or b, this is b, sorry, this is a, we are using the same letter a. So we have a equals to minus 4. Now when you substitute a, that is equals to 9 into equation 3. So when you substitute, you are going to have b equals to 5 minus 9. So we want to determine when a equals to 9, b will be minus 4. And when a equals to minus 4, b equals to 5, then substitute minus 4 for a. We have minus 4. You are going to obtain 5 plus 4, which is equals to 9, which implies the equation is symmetric. Because the value of a, when you interchange, you are going to obtain the same thing, which implies when a equals to 9, b equals minus 4. And when a equals to minus 4, b equals to minus 9, which implies, when a equals to minus 4, b equals to 9, this time around, b equals to 9. So it implies that the square root of the complex number we are given, so that is we have square root of 5 plus 12i equals to, now we can write it as square root of a, we can use 9 for a and we can use minus 4 for a. But when you are using 9 for a, you are using minus 4 for b. Square root of minus 4. So which implies square root of 9, 3. Square root of minus 4 can be written as square root of 4 multiplied by square root of minus 1. So which implies 3 plus square root of 4 is 2. Now square root of minus 1 is I, that will be 2i. That is the answer to the question. Therefore, the square root of this equals to 3 plus 2i. That is our answer, the answer to the question we are going to solve. Thank you. Please like, comment, and share. If you have any question, you can drop in the comment section. Thank you.